The purpose of this video is to walk you through the two-layer schedule process, explain how it was built, why it was built the way it was, and how you can use it. So a two-layer schedule is any schedule that's comprised of main IDs and sub-IDs. So a main ID could be a container, it could be an order, a test tube, anything like that. And then the sub-IDs for containers might be pallets or cases. For orders, it would be the items in the order. For test tubes, it could be the tests that are going to be run on that tube. In this sample model, we have a series of Connex containers, 25 of them, and then each Connex container has a set of SKUs assigned to it. Each SKU has an arrival time and a quantity. The process flow that controls everything is comprised of three different flows. The schedule control flow, which is the control token. It has a main ID process flow, which is where all of the main ID tokens will reside, and a sub ID process, which is where all the sub ID tokens will reside. The control token is the only token created on reset of the model. So at the very start, we only have one token. The first thing we're going to do is set up that control token. And this is where we set the name of the table that we're going to use. We set the column number that has the main ID, a column for the sub ID, a column for the arrival time of the sub ID, and a column for the quantity of each sub ID. So if you were going to use this process flow in your own model and you copied it over and you had a different table, you could set that name here, and you could also set what columns were going to control the quantity, the time, and the two IDs in this location. As you can see in our table over here, it's not sorted by container, which is the main ID, it's sorted by time. And that's not going to be really helpful for what we're trying to do. So the next thing that the control token is going to do is it's going to sort that table by the main ID and then the time. So the code for that is not as scary as you might think it would be. We're simply saying the table that we have the name for, and then we're using this .sort function, and we're telling it that we want to sort by the column of the main ID and then the column of the time. And we have a 1 here, so we're going from smallest to biggest. So if we want to see what that's going to do, I'll just click on the table over here. And then if we step, we're going to go 1, 2, 3, and now we've sorted the table. So you can see that all of our number 1 connexes are right here at the start. We have all of our times sorted as well. And then we have our different SKUs and the quantity for each one. The next thing that our control token is going to do is it's going to go through each row of our table, and it's going to basically look to see when it finds a new unique ID. So it's obviously going to find one at the very start because it hasn't done anything yet. And then for that unique ID, it's going to go through and count the number of sub IDs that it has. And then when it gets done with that, it's going to create a token for that main ID. So we'll step through for this first one. So we found a unique ID. So we're going to set up some labels so that we can count that. The next row is still the same ID. So we're going to go through there. This has 5. So the next row is still the same. The next row is still the same. The next row is still the same. But now we're on row 5. And this row 6 is going to be different. So when we hit step, we're going to go out of that and we're going to create a main ID token. So the labels on our control token, we have the name. Our current row is 5. Our current main ID is Connex number 1. And then we started on row 1 and we have 5 different sub IDs associated with this. So when it creates that token gets set up with some labels on it so that we know what row it started on, what row it ends on. We know how many sub IDs it has, the ID, so the main ID is Connex number 1, and our arrival time, and it's using that first row arrival time, so that earliest arrival time is going to be 0.18 seconds. So now our control token is going to see if there's more rows in the schedule. There are, so it's going to come up, increment the row to number 6, and then start to look to see if there's a new ID, right? So it's going to find that, yeah, this next row, row 6, was Connex number 2. So it's going to come through and count how many rows there are for Connex 2. And then once it finds out how many rows there are, it's going to create the Connex 2 token and then drop down here and just basically keep looping through the whole schedule. And it will create all of the main ID tokens. Okay, so we've skipped through and we've created all of the different Connex or main ID tokens. And this first one arrived at time 0. So when I hit the skip button, it just created all of its sub IDs as well. But what we're going to do is step through and we're going to follow Connex number 1 that showed up at 0.18 seconds and see what it goes through. So it's delayed until the start time. So now it's going to inform our control token that the main ID has started. And then it's going to drop down and it's going to create a sub ID token for each of the sub IDs inside of it. And when those tokens get created, they know what row of the table that they're a part of, they know what their ID is, and they know what their quantity is supposed to be. And they also have an arrival time that's how many seconds past the arrival of the main ID before they can start. So the first row is always going to be 0 because that's the earliest, but the second one in this case is 31:55. So over here in our table, we can see that we have 0.18 seconds, and then at 31:55.18, our second one arrived. So that's why the arrival time here is 31:55. So it will go through and create a sub ID token for each of the sub IDs, and then it's going to drop down and wait. So it's pulling from a list, but really all it's doing is it's waiting for all of the sub ID components to start. And then once all of the sub ID components start, it will inform the control token that all of the sub IDs have started, and then both will just drop down into storage. So the purpose of doing this is because you can use the control token to control your model. So if it's always monitoring the process of the main IDs as they go through, then when all of the main IDs finish with whatever they have to do, you can use that to record the time. So if you had containers arriving, like in this instance, we would know, okay, from the start of the model, when did the last container finish certain things? And we could track that here. You can use it to control when you want to end the model. So if you don't really know how long it's going to run, but you know that once, say we were putting away all of these SKUs, once all of the SKUs have been put away, we want to know when to stop the model. We could do that here. And so with using lists to push and pull. So if we look at this list right here that it's currently on, it's just waiting for the number of children. So that's how many it's pulling. And then each child token pushes to the list, and then they don't wait, they just continue on through, because we don't want these to stop just because all of them haven't gotten there. Obviously, they have other things that they need to do. And then we're doing the same thing with the sub IDs. The only difference there is that for the sub IDs, we're using the token, so the main ID is the partition. And that's because now instead of one control token pulling from the list, we're going to have multiple control tokens pulling from the list. So each control token, we're partitioning the list by them. So when the child informs that they've started, they're partitioning off of their parent. So what this allows us to do is, as the sub ID tokens go through the model, we can inform the main ID and then they can inform the control token. So for these sub IDs, right now, what we're doing is we're just delaying till their start time, and then we're calling it a day. But what we could do is we could have each of these go through a process time where they create their quantity and put them on a conveyor, and then that conveyor could take them somewhere else in the model. And when they get to a certain location, these Sub-ID tokens could be listening for that and know when they get there and when they finish, and then come backwards. For these main ID tokens, some interesting things that we could do that I'm sure we'll do in a later model or a video is we could have each of these containers have to get a hold of a dock. So once they've arrived, they have to get control of a dock, and then that dock would then unload each of the cases for the sub IDs. So there's many interesting things that you can do after the storage component of the model. But the purpose of this model was just to show how you can create those tokens efficiently and do it in a way where you can continue to track those tokens later on through the model. This is something that I personally do quite often. So I wanted to make this model because I plan on keeping this on the side and then using it whenever I need to do this in the future. I can just grab this, paste it into the model, change those labels, and move on.